Welcome to the session on trigonometry and modelling, double angle formulae. The objectives for this session are to understand and use the double angle formulae. In the last session, we looked at the addition formulae. In this session, we're going to use these to prove the double angle formulae. Let's begin with the addition formula for sine. If we let A equal B in the formula for sine, we obtain sin A plus A is identical to sin A cos A plus cos A sin A. And therefore, if we tidy up, we obtain sin 2A is identical to 2 sin A cos A. And this is our first double angle formula. Let's now take a look at the addition formula for cos. If we let A equal B in the formula for cos, we obtain cos A plus A is identical to cos A cos A minus sin A sin A. And so if we tidy up, we obtain cos 2A is identical to cos²A minus sin²A. And we can rearrange this to be written as cos²A minus 1 minus cos²A. We've of course replaced sin²A by 1 minus cos²A. And this gives us 2 cos²A minus 1. So cos 2A is also identical to 2 cos²A minus 1. Similarly, we can write cos 2A as being identical to 1 minus 2 sin²A. Now let's take a look at the formula for tan. Again, if we let A equal B in the formula for tan, we obtain tan 2A equals tan A plus tan A all over 1 minus tan A, which is identical to 2 tan A all over 1 minus tan²A. And this is the double angle formula for tan. We're now going to use the double angle formulae as shown on your screen to explore some examples. Pause the video and have a go at this example. When you are ready to view the solutions, press play. So let's take a look at part A first. We're required to use the double angle formulae to write cos² pi by 8 minus sin² pi by 8 as a single trigonometric ratio. So let's solve this. Using the double angle formula for cos, we have that cos² pi by 8 minus sin² pi by 8 equals cos 2 times pi by 8. Here, of course, A has been replaced by pi by 8 in the double angle formula for cos on the left-hand side of your screen. And of course, cos 2 times pi by 8 is equal to cos pi by 4. Now let's take a look at part B. We are required to use the double angle formulae to write 2 tan 100 degrees all over 1 minus tan² 100 degrees as a single trigonometric ratio. So let's solve this. we are of course going to use the formula for tan. Here we've substituted A equals 100 degrees into the double angle formula for tan as shown, to give us tan 2 times 100 degrees, which is of course equal to tan 200 degrees. And now for part C, we are required to use the double angle formulae to write 8 cos 50 degrees over cosec 50 degrees as a single trigonometric ratio. So let's solve this. We can leave 8 as it is. 1 over cosec 50 degrees is equal to sin 50 degrees. And cos 50 degrees can be left as it is. You may be able to spot sinA+cosA somewhere in the double angle formulae. And if you can hopefully see why we've split 8 as 4 times 2. This of course now allows us to use the formula for sin²A, which is identical to 2 sinA+cosA. Here we've replaced A by 50 degrees. So we have 2 sin 50 degrees cos 50 degrees equals sin 100 degrees. And therefore this expression equals 4 sin 100 degrees. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. In this example, given that P equals 2 cos theta and Q equals cos 2 theta, express Q in terms of P. So let's solve this. The equations can be written as cos theta equals P over 2 and Q equals cos 2 theta remains the same. Now since cos 2 theta is identical to 2 cos² theta minus 1 for all values of theta, and Q equals cos 2 theta, we can replace cos 2 theta by 2 cos² theta minus 1 as shown. And of course cos² theta equals P over 2 all squared as shown. And so we've expressed Q in terms of P as shown. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. Given that cos x equals 1 over 4 and that x is between 0 degrees and 90 degrees, find the exact value of sin 2x. So let's solve this. We know that sin² equals 1 minus cos². And so if we replace cos x by 1 over 4 as shown, we obtain sin² x equals 15 over 16. Now since x is between 0 degrees and 90 degrees, we have sin x equals root 15 over 4, since x lies in the first quadrant. And therefore, using the double angle formula for sine, which is sin 2x equals 2 sin x cos x, and replacing sin x by root 15 over 4 and cos x by 1 over 4, we obtain that sin 2x equals root 15 over 8. Now let's take a look at part B. Given that cos x equals 1 over 4 and that x is between 0 degrees and 90 degrees, find the exact value of tan 2x. So let's solve this. Now from part A we know that sin x equals root 15 over 4. And so since tan equals sin over cos, we can simply plug in the values of sin and cos. So we have root 15 over 4 over 1 over 4 to give us that tan x equals root 15. Now we can use the double angle formula for tan. And plugging in the values of tan x gives us that tan 2x equals 2 root 15 over 1 minus root 15 squared, which when tidied up is equal to minus root 15 over 7. This brings us to the end of this session. If you have understood its contents, you should be able to understand and use the double angle formulae. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.